Welcome to the CFE Media and Technology Education session, Understanding Cost Ownership for Motors and Drives. I'm your moderator, Mark T. Hosky with CFE Media and Technology. In keeping with our CEP policy, please take some time to read the quality assurance slide. This session is designed for technicians and engineers who want to know what to consider when evaluating total cost of ownership, including initial cost, reliability, downtime, maintenance, product lifecycle considerations, warranty, and more. Here is a list of learning objectives. We'll cover these in today's presentation. Additional resources can be viewed and downloaded on the left side of the screen below the session's agenda. For a seamless online experience, here are some tips. Additional resources can be viewed and downloaded on the left side of the screen as mentioned. If you'd like to take notes within the session, click on the left panel labeled Notes to do so. This session is available on demand if you need to come back at any time. Please remember that the session will be made live at 12 p.m. Central, 1 p.m. Eastern, with the Q&A starting approximately at 12:45 p.m. Central and 1:45 p.m. Eastern, or immediately after the presentation ends if it runs a little longer than 45 minutes. Industry experts will answer viewer questions live, and those answers will be archived with the session. You can see the Q&A details in the Meetings tab on the left side of the screen. Here's some information about obtaining an approved PDH for today's session. Today's roundtable participants are Daniel Martinez, Medium Voltage Motors Product Manager, Motors and Drives Division, Mitch Clark, Director of Oil and Gas Sales, Motor and Drives Division, John O'Brien, Director of Distribution Sales, Motor and Drives Division, all with Toshiba International Corporation. I'm your moderator, Mark T. Hosky, Content Manager, CFE Media and Technology, and now a little more about each panelist. Daniel Martinez has more than 17 years experience in the motors and drives industry. He serves as the Medium Voltage Motor Product Manager for Toshiba International Corporation. From product development to aftermarket services, Daniel has held a wide range of leadership positions at Toshiba, including Senior Field Services Manager and Test and Quality Manager for Control Systems Manufacturing. Prior to Toshiba, Daniel served in the U.S. Marine Corps. Daniel has a strategic MBA from the University of Houston, Victoria, and a Bachelor of Science in Electronics Engineering Technology from Texas A&M University. For over 26 years, Mitch Clark has served in a sales role with Toshiba International Corporation. He has the unique experience of offering motor and drive products into many different industries and applications, which has allowed him to gain an excellent understanding of customers' needs and expectations. As Director of Oil and Gas Sales, he's currently responsible for a dedicated team of professional sales individuals focused on capital oil and gas projects on a global basis. Mitch earned a Bachelor of Science degree in Mechanical Engineering from Texas A&M University and currently resides in Austin, Texas. And John O'Brien has 39 years of leadership in the motors and drives industry. With 34 years at Toshiba International Corporation, he currently oversees the distribution network as sales director. John's customer-first mentality has allowed him to successfully grow Toshiba's distribution network and develop expertise in a variety of industrial applications. Through his support of distributors, end users, and OEMs, John understands the importance of lifetime costs and ensuring customers are making the right decision for their application. John holds a Bachelor of Arts in Marketing from Illinois State University. And now we'll go to the panel discussion and move through a few slides as we do. So on the first slide here, what does it really mean when we talk about total cost of ownership for a motor and an adjustable speed drive system?
Yeah, thanks, Mark. This is Mitch Clark. I want you to think back and remember the last time you purchased a vehicle for yourself or your family. I suspect one of the things you remember is the initial purchase price, correct? What you may not have been thinking at that time was all of the other costs that you would incur over the life of the vehicle, such as the fuel cost each time you fill up, the maintenance costs like oil changes, brakes, belts, fluids, tires, etc., as well as the additional expenses after an unexpected breakdown, such as tow trucks, rental cars, and potentially lost wages from missing work. It's not hard to see that by adding up all these additional costs, the initial purchase price becomes a much smaller percentage of the total life cycle cost of the vehicle. Similarly, it is not uncommon for large capital expenditures that include motors and drives to be made simply based on the initial purchase price. But, like vehicles, and even more so, there are many other factors that smart companies consider to minimize their total cost of ownership for these products. And only by considering every aspect that contributes to the cost can you determine the real total cost of ownership. For example, if you are purchasing adjustable speed drives, especially large medium voltage drives, what is the cost for the real estate where these will be installed? Oftentimes, these drives are installed in electrical houses or control rooms. A drive with a larger footprint will require additional costs for a larger building. You should also consider the cost for a cooling solution along with the monthly cost to operate that cooling solution. Many people don't realize it, but a typical 1,000 horsepower medium voltage drive requires the same cooling requirement as your average 2,500 square foot house. This requires not only a large upfront cost, but also monthly energy costs and yearly maintenance costs. And don't forget about the reliability of the cooling system. In the case of air conditioning cooling, it doesn't matter how reliable your adjustable speed drive is if the air conditioner cooler that the drive is being cooled by is not working. And speaking of reliability, as we all know, reliability is directly tied to uptime. When your drive or motor is down, there is a cost to your company in lost production. In many applications, the cost of lost production can easily dwarf the initial purchase price and is thus an extremely important consideration. The reliability of both the adjustable speed drive and the motor should be considered. Now, many low voltage drive topologies are very similar, but there are vastly different medium voltage drive topologies out there. Things to consider for medium voltage drives include fusing to protect both the primary and secondary side of the phase shifting transformer, a soft charge circuit on the primary side of the transformer to minimize inrush currents, which will extend the life of the transformer, and the type of critical components such as capacitors and transistors, and the ratings of those components, as well as the total number of those critical components. Every component has a failure rate, which means that the more critical components included in a product, the higher the chance of failure of that product. For motors, the important factors that contribute to reliability include bearing size, temperature rise of the windings and bearings, the type of materials used, and the quality of the manufacturing process. Unfortunately, there are no perfect manufacturers, nor are there any perfect products, so problems will eventually occur. But before those problems occur, and hopefully before the product is even purchased, it is critical that you consider a manufacturer with a sufficient installed base to support an extensive network of service, including including readily available spare parts in order to help minimize your downtime. Another consideration is the warranty or lack thereof. Does the manufacturer offer an extended warranty on both the motor and the drive? Does the manufacturer even offer both motors and drives? Having single source responsibility can eliminate finger pointing, which will minimize delays in problem solving, thus minimizing downtime. Some other less obvious factors that contribute to the total life cycle cost include things like product lifecycle considerations. So your long-term investment is not obsoleted in a few years, making parts difficult or even impossible to source. Also, the manufacturer's experience and reputation should be considered to make sure the company will not only be in business for the product's life cycle, but will also be able to competently support the products throughout that time. But there is one factor that has the largest contribution to the life cycle cost of your motor and drive system, and that factor is the cost of energy.
So among these 10 considerations, would energy be the most useful in creating a project justification, or do the other factors work in as well?
Yeah, good question, Mark. If we're talking about justifying a project that is just replacing existing motors or drives, energy is definitely one of those considerations. If you have an older, less efficient motor, for example, that can be replaced with a higher efficient motor to reduce your operational costs, that can definitely be one factor in creating justification for a project. But there are a couple other factors as well, such as the reliability of the product. If it's at the end of its life or it's having continual unplanned problems, you may want to replace that product to have more uptime. Further, if you are experiencing poor service or a lack of spare parts availability from the manufacturer, they may not have an adequate service network. Also, you may have a product that's at the end of its life and you need to replace that product in order to make sure you're operating with the maximum uptime for as long a period of time as possible. So there are many different factors, including energy, that can help justify a project.
Efficiencies of motors have been increasing over time. Could you explain more about how energy costs are the largest contributor to the total life cycle cost?
Thank you, Mark. This is John O'Brien. Energy consumption is the greatest cost of operating and owning an electric motor. As you can see on this slide, the example motor of total cost of ownership, energy costs over the life expectancy of an electric motor is 96%. For many companies, motors and drives are out of sight and out of mind. Sometimes they are tucked away in the back of your plant or hidden inside a piece of equipment. When you receive your monthly utility bill from the power company, there's no line item on the bill for you to determine what your cost is to operate each motor in your facility. The National Electric Manufacturers Association, NEMA, defines standards used in North America for many electrical products and enclosures. These standards include electric motors up to 500 horsepower for 600 and below machines. For motors 500 horsepower and below, NEMA has created standards for efficiency. Motor manufacturers usually publish this motor efficiencies within their literature and also provides the motor efficiency data on their motor nameplate. What if you have a requirement for a motor above 500 horsepower? There are no NEMA standards for motor efficiency for a manufacturer to meet. As the purchaser, you will be subject to a manufacturer's motor design and efficiency of that machine. Many companies, when purchasing large horsepower motors, consider these purchases capital expenditures. Most motors are above 500 horsepower can cost tens of thousands of dollars in the initial purchase price. Since there are no NEMA standards for these motors, you can have a significantly different electrical consumption to operate the motor. And these are considered capital equipment and expected to have a long life of 10 plus years. So here's an example to put a total cost of ownership in perspective. Let's take the example of purchasing a 100 horsepower motor. And if you can see there, the efficiency is 92.7%. And this motor is operating 24 hours a day, 7 days a week, and it's fully loaded. And your cost per kilowatt hour is 10 cents. The energy cost per year is over $70,000. But if you decided to use a premium efficiency motor, you can see the increase in efficiency went from 92.7 to 95.4%. The energy cost per year is $68,000. So you have an annual savings of $1,996. But think about the actual cost and the life of that motor. A 100 horsepower motor can easily last 10 years. And if you having that motor, that would put that cost of energy consumption in it over its life over $600,000. Maintenance costs are for the first year are pretty minimal. Basically, would have the cost to grease the motor, and depending on the manual, it could be 2 to 3 times a year. But over a 10-year life, I would expect that you would have to replace the bearings maybe once or twice. You might even have to rewind the motor. And even with those expected maintenance costs, those costs are only going to represent 1% of the initial purchase price, the cost of ownership. You can expect to have an electrical consumption cost of well over $600,000 to operate that motor. Go to the next slide, please.
John, let me just ask, given the large cost of energy, are there investments that people should be making that they're not? Are people leaving money on the table because the line item falls in another department or because they don't do these calculations?
I think there's no doubt that most purchasers of electric motors are unaware of what the operating costs are. We focus so much on the initial purchase price that we overlook that what it actually costs to operate that motor.
Great, thank you. So are there any efficiency standards for adjustable speed drives?
Yeah, Mark, to my knowledge, there are no standards that mandate the efficiency of either low or medium voltage adjustable speed drives. Most low voltage drives have a similar topology with a diode front end, capacitors, and a transistor output. And the efficiency of those topologies is typically around 97%. This value is similar for medium voltage drives. However, there are some differences that may affect that value, such as aluminum material versus copper and key components like the input transformer. There are some manufacturers claiming higher efficiencies of their medium voltage drives, even up to 99%. But be careful, as this may not include necessary components shown here in the slide, such as input transformer or reactor, the converter section, the inverter section, or any output filters that may be required, especially for 3-level output topologies in medium voltage drives. But efficiency is more than just the product itself. Unlike motors, most adjustable speed drives are mounted indoors. Like motors, most of the efficiency losses are in the form of heat. Therefore, the heat loss from your adjustable speed drive must be dealt with to keep the equipment from overheating and potentially failing. Some of the common methods to deal with this heat include using water cooling, air conditioning, or large heat exchangers. Now, each of these methods has advantages and disadvantages, but they all require power to operate and thus should be considered in the total life cycle costs. There are some manufacturers offering outdoor drive solutions that eliminate that additional expense, as well as eliminating unreliable air conditioners and or water cooling systems.
So if I understand correctly, adding an adjustable speed drive to a system could actually reduce the overall system efficiency? So what are the reasons for using adjustable speed drives?
Well, Mark, one of the first reasons there is process control. When you use a adjustable speed drive in an electric motor, you now have the ability to speed up or slow down the motor that would offer you a more precise motor control and in speed control for your application. Another reason to use an adjustable speed drive is the ability to soft start the equipment and reduce mechanical wear and tear. So understanding the differences in what we say is starting an electric motor versus accelerating an electric motor. When you start an electric motor, you're going to have 6 to 10 times inrush current into the motor, which it has a violent starting process. With a variable frequency drive, you have the ability to control the acceleration of the motor by setting parameters inside the variable frequency drive. In many cases, you can set the acceleration time up to maybe 6-7 minutes. But in most applications, you can start and accelerate an electric motor in, say, 15 to 30 seconds. So you have the ability to soft start the equipment, and you prevent any type of mechanical wear and shock to the driven equipment. Another reason to use an adjustable speed drive is eliminating motor inrush. Again, it gets back to starting versus accelerating the motor. As I just explained, with adjustable speed drive, you basically program the drive to accelerate up to full speed, but you start at 0 frequency and 0 voltage, and then you control the amount of inrush that the motor sees, which reduces the demand charges. And this is very important in very large horsepower motors. So for example, if you're starting a 500 horsepower, 800 horsepower, 1,000 horsepower motor, if you can eliminate the motor inrush, you'll certainly have the ability to reduce potential demand charges that would be imposed by the utility. Another advantage of using a adjustable speed drive is that you can have as many starts as you would like with an electric motor, because you don't see any heating that would go into the rotor of the motor, because you're accelerating the motor starting from 0 voltage and 0 frequency. Another advantage of using an adjustable speed drive with an electric motor is that the system has a power factor to minimize utility penalties. If you opened up a variable frequency drive, what you would see is there's many capacitors in there that are actually working to increase the overall power factor of your system. And probably the most common reason to use an adjustable speed drive is the energy savings on variable torque applications. And if you understand the affinity laws for centrifugal pumps and fans, you can eliminate mechanical dampers and valves in your system. So for example, if you're running a centrifugal pump and you wanted to reduce flow without a variable frequency drive, you would have to use a valve and reduce the flow. But with a variable frequency drive, all you have to do is reduce the frequency. And if you reduced it by 20%, you'd actually receive a 50% power to run the motor. So you'd have a significant savings. So those are just some of the reasons why you would use an adjustable speed drive.
And John, Mitch here, I'd like to add to that last point, a common analogy that I use when you're talking about replacing a control valve with a drive. By using a control valve, I'll go back to my vehicle question. It's like controlling the speed of your car by holding the accelerator all the way to the floor and using the brake to control the speed. It's just a tremendous waste of energy.
Right. This is Daniel, and I'd like to add on to something that John mentioned. He mentioned the inrush current of the motor, and yes, that is a drain on the energy system, but it also heats up your motor. And most motors, when started across the line, are rated with so many starts per hour. When you remove that violent inrush, you're able to start your system multiple times a day, multiple times an hour, without ever having to worry about excessive heating, because you've never exceeded the full load amps rating of the motor. You also have a little bit of more operational control. Every system has some kind of resonance. A variable frequency drive will often allow you to be able to move past any critical frequencies you may have in your system without landing and staying on that critical frequency, causing unwanted vibrations and causing your system to begin to resonate. Another advantage of a variable speed drive is our electrical systems in the US are mostly at 60 hertz, and motors across the line are meant to run at one speed based off of the frequency it's being fed, depending on the number of poles. With a variable speed frequency drive, that is no longer a limitation. You can go down to 0 hertz, you can go all the way up to 60 hertz. With a variable speed drive, you can go beyond 60 hertz, and you can overspeed a motor and go into a constant horsepower range. So a variable speed drive, along with a properly designed and paired motor, can give you a lot more flexibility, not only for potential energy savings, but also operational flexibility.
And Daniel, not a bad idea to consult with the motor and drive manufacturer when you are talking about varying the speed to either extremely low or overspeeding your motor, just to make sure that the equipment is capable.
Absolutely correct.
So a lot of good information there. Can we step back and talk about the bigger picture of how a company's culture can affect the purchasing decisions?
Yes, Mark, thank you for that. So one of the things that I think we should kind of define company culture. So company culture is defined by the beliefs and behaviors that determine employees and management interactions. Often a company's culture is implied, developed over time from traits of the people the company hires. So let's take the culture of the purchasing department. And purchasing, it's normally measured by how they can find ways to lower cost of items that they need to buy for operating their company. A company culture for the purchasing department could be a measure of how much the purchasing department can reduce their spend year over year. I'll give you an example of when I was calling on a large agricultural company located in the Midwest. And for many years that I called on them, their requirement for electric motors was to purchase the most inexpensive motor they could. Or their attitude was that it was acceptable to run their equipment until it failed. Eventually, there came a shift in the purchasing of electric motors to buy a higher quality motor, and they went from the least expensive motor to what I would consider a much more expensive motor, and they ended up buying 841 motors for their processes. This shift in focus was to improve plant reliability. Their change could have resulted from many factors: changes in management style, changes in personnel, reviewing their downtime cost and looking ways to cut it. Mitch, do you have any comments about maybe the culture of a production department?
Yeah, excellent points, John. As Director of Oil and Gas Sales, we're involved with many different midstream companies that move millions of dollars of product through their pipelines each day. And fulfilling their customer commitments requires maximum uptime from their motor and drive controls for their pumps or compressors. So they heavily consider many other factors other than an initial purchase price when they're considering their motor and drive systems for those critical applications. Daniel, do you want to touch on maintenance consideration here?
Yeah, so I spent a good portion of my career on the maintenance and support side of the business, and the common things that especially large companies want to know is how do I service my equipment? How do I get it serviced? Like Mitch said earlier, no company is perfect. No piece of equipment is perfect. You're always going to have, or you can expect that an issue may arise at some point in the lifespan of any given piece of equipment. And it's really important how the manufacturer of that equipment is set up to respond to the need of the customer and the support network that's behind that manufacturer. And it's important to understand, do I have local support that I can call on and they can be there, within 12 hours or some acceptable time frame? Or am I so remote that I may have to learn how to do this on my own? And do I have the ability to do that? Will the manufacturer let me do that? We've had customers out in the middle of nowhere, Alaska, that absolutely needed to have the ability to not only maintain, but start up and service their own equipment. And for that manufacturer, or excuse me, for that customer, is very important because they could not afford to be down. And their ability to do that really guided their choice in manufacturers. The ease of getting service, the ease of doing business with the service department. Can you call that manufacturer and 24/7 and have someone pick up the phone that's knowledgeable? Or do you leave a message and you get a call the next day? Do you need to have an account number and a line of credit open for them to answer your service call? These are things that you don't know, sometimes you don't even know about until it happens, and you have to learn the hard way. And they are very important because critical applications, hours can cost thousands and thousands of dollars an hour. And the inability to be able to get a PO signed, to get a line of credit, to get questions answered on a simple support line can be very, very detrimental to a process. You have to look at parts. Are they available? Where are they available from? Are they sourced locally? Where are they warehoused? How can I order those if I need to? Can I train my people to, can I train my people to do the work themselves? Is the equipment set up in such a way that you don't have to have a bachelor's degree in engineering to go in and do the majority of common repairs that may have to be done, or any of the maintenance that may have to be done? There'll always be someone who can provide those services, but if you're in an area where it's just not cost effective to do that, are you able to do that on your own, with the support of the company? What about how long it takes to repair something? Every manufacturer will have common failure modes, and each one of those takes certain parts in a certain amount of time to repair. What are those? How is it done? Are those things that a end user can keep in stock? Is that something that my distributor has in stock? How long does it take if I have it on site to repair? Once again, can I repair it myself? What level of support will I have while I'm doing this repair? The maintenance side is just as important as everything else, because once the sale is done, once the application has been designed, once the product is flowing, everybody puts, thinks that the hard part is over. And the reality is that the hard part's just beginning, right? Because the year or two that it took to put the project together, buy it, build it, and install it, is you have a bunch of people involved. After that, the next 10, 15, 20 years of that system running is really where the money's made or lost, depending on the reliability of the equipment and the service capabilities and network behind it, whether it be in your own company, in your servicing distributors company, or all the way out to the manufacturer support if needed. So those are the areas that often get overlooked by just the buyer, someone that may not have experience with failures of equipment. They're just worried about getting that next project finished, getting it under budget and on time. But it's very easy to overlook the long term. That's what we're talking about, total cost of ownership. What's the long term cost if we don't plan properly and set up the right service plan, service network, and service capabilities for the equipment?
Yeah, excellent points, Daniel. And you touched on reliability there, and I touched on it earlier with the production discussion, but along with preventative maintenance programs that can help extend the life of your equipment, some manufacturers are actually offering ways to automatically send data in the event of a fault that can be quickly analyzed to minimize downtime. And as companies continue their research into the industrial Internet of Things, you hear the term IIoT, that's involved with this. And it's not hard to see a time when products alert you to potential issues before you have a failure so that those can be addressed during a scheduled downtime event. So all of that considered, you would obviously increase your uptime and improve your reliability. And I want to touch on one more thing. The most important factor really at the end of the day is safety. We all want to return home safely to our families and friends. And it's imperative that manufacturers take this into consideration to design safety features into their products without significantly affecting the capital expenditure requirements. So things as simple as an integrated disconnect switch in your medium voltage drive can make the difference in a safe lockout tagout procedure and a significant injury or even death. So safety should certainly be one of the considerations taken into account by all groups when making purchasing decisions. John, do you want to touch on the engineering piece of this?
Well, I think just as everyone says, understanding the products that are being supplied and having the discussions with the manufacturers prior to purchasing all go into a successful project. Understanding all these, the supply chain's needs will help for a successful project. So again, I think they're all equal in value, but again, I think it gets back to the company culture and how they view these various departments. In some cases, some departments can have a greater value, but not necessarily overall. So in my mind, when I'm thinking about this type of project, all of these departments should have an equal value and an equal input into the actual purchase of the equipment.
Yeah, and many of these items that we've discussed can be included from an engineering perspective in the specifications required for the capital project. So that should be something that the engineering group is discussing with each of these groups as well.
Great. That's a very interesting take on how a company's culture can affect a wide range of groups and considerations for your motor drive system purchase. As we near the end of our time, would you like to close each with a brief summary?
As we discussed, there are many factors that contribute to the total life cycle cost of the motor and adjustable speed drive system. There are many different groups within the organization that are affected by the purchasing decisions that are made. The initial cost, that's what everybody looks at. That's what every single purchase, regardless of the breadth of their knowledge, will always look at initial cost. Where you start stepping it up is into reliability. What's your experience with the manufacturer that you're choosing? Do you have relationships with their support networks? Downtime, understanding how important is this piece of equipment to my process. If this goes down, what are my costs per hour if this goes down? And how quickly can I address that issue? The maintenance, the long-term, the 10, 15-year costs of keeping the equipment running well. Machinery should should run for years and years if it's properly maintained. If it's not properly maintained, you can have a very, very, very reduced life cycle for that piece of equipment. And so having a good maintenance plan in your company, if you don't have a good maintenance plan or you're not familiar with this type of equipment, reach out to the manufacturer or their sales arm, and they will absolutely help you put something together, whether it's something they supply or something they help you create internally. The product life cycle. If I buy a piece of equipment today and I find out that they've been working on the next best thing for the last 5 years, 2 years later, the next best thing comes out, well, how long am I going to get support for this? It's, I expect this to run for 10, 15, 20 years. 2 years into my purchase, that now just became obsolete. How long are they going to be able to keep critical parts on hand, and are they going to be available for how long? We've gone over the cost of energy pretty extensively, and then it comes down to the warranty. How does a manufacturer? Not all warranties are the same. Some manufacturers will just have parts only warranties. Some have parts and labor. What if we have to send somebody out there? Is that warranty going to cover parts, labor, travel, expenses? All of these things could add up to thousands of dollars a day. Plane tickets. Those are considerations that aren't on the PO that you normally don't see, that you normally don't take into consideration. But apples to apples, when you look at, I've got to keep this thing up for the next 15 years, 20 years, those are real considerations.
Great, thanks. Any other closing comments?
Yeah, hi, this is John. I think, again, understanding the company cultures that consider all of the above are the ones that truly experience the lowest total cost of ownership.
Good. All right. We've gone through a lot of great material. I thank our panelists very much, and please, I would invite everyone to transition over to the Q&A, question and answer portion of the presentation. You can use the live Q&A information and invitation in your Zoom invite details, and the details can be found in the Additional Resources tab on the left side of your screen. Thanks again to our panelists, and we'll see you in the live Q&A.